In this video, I will speak about circle geometry. First of all, in the circle, diameter equals double the radius, or 2 times the radius, and circumference 2 by r, or d pi, okay? And the area is pi r square, okay? In the circle, the line passes through the center and perpendicular to the chord, okay? Then it bisects the chord, okay, and vice versa. And if it bisects the chord, then it's a perpendicular. In the circle, the radius or the diameter are perpendicular to the tangent, okay. In the circle, the two tangent segments which are intersected at a point outside the circle are equal in length, okay. After that, this angle is called central angle, and this angle equals the measure of the opposite arc or subtended arc, and this angle is called inscribed angle, and this angle equals half the measure of the subtended arc, okay, and also equals half the measure of the central angle which is subtended by the same arc, okay. And there is also another angle is called the angle of tangency. An angle of tangency is between a tangent and a chord, okay? And this angle is half the opposite arc, okay? يعني same like an inscribed angle, okay? يعني if this angle is 80, so this angle will be 40 degree, okay? And here, this angle, it's not central, and it's not inscribed, and this angle equals half the sum, okay, I call it x, half the sum of the opposite arc and behind arc, okay. And also there is another relation which is AB time BC equal EB time BD, okay. In this case also, this angle is exterior, and its measure equals half the difference of this arc and this arc, يعني the opposite two arcs. And here, and also CB times CA equals CD times CE. And in this case, AB square equals AC times AD, okay? And also in the circle, if you need to convert from measure of arc to length of arc or vice versa, you can use this rule. X degree, the measure of the arc, over 360 equal length of arc over 2 by r, okay? And also if the chord equals the chord, then the arc equal arc. And here, if AB equals CD, then AE, or ME, sorry, equals MF, okay? If the two chords are parallel, then the subtended arcs between them are equal in measure, okay. And here in this relation, the circular sector, okay, the circular sector is this shaded area with pink color, okay, and this angle is the central angle of it, and this is a radius, and this is a radius, and this is length of arc, okay. Theta radian, this angle in radian measure equals length of arc over the radius, and the area of the circular sector equals half LR. And also another rule, the area equals half theta radian r square. And here also, this is an important proportion about the circular sector. Theta degree, okay, over 360 theta degree is this angle, central angle, or the measure of the opposite arc. They are same. Theta degree over 360 equals length of arc over 2 by r equals the area of sector over by r square, okay. And then here, cyclic quadrilateral, okay. In the cyclic quadrilateral, which is a quadrilateral whose its vertices lie on the circle, okay. So the opposite angles are supplementary. Their sum equals 180. And here also the exterior angles equal the interior angle opposite to its adjacent, okay. And here, this angle equals this one, and this one equals this one, and this one equals this one, and this one equals this one, if the figure is cyclic quadrilateral, okay. In this case, this is a very important case. If there is a circle inscribed in a triangle, so the radius length of the circle equals the area of the triangle over half perimeter of triangle. Okay. After that, this angle is called an inscribed angle of a semicircle, and its measure is 90, and it's always opposite to a diameter. And here, this shape is a semicircle or half circle. This arc length is pi r because all the circle is 2 pi r. So this is pi r. And this is a diameter, and this is radius, and this is a radius. In the semicircle, its area equals pi r square over 2, and its perimeter pi r over, plus diameter. The circle equation. The circle equation, we have two equations. The first one related to the center and the radius length, okay? So x minus h square plus y minus k square equals radius square, and the center is h and k. Yani you will inverse these signs, okay, to be here. And the radius equals the square root of the value outside after the equal sign here. And also here, we have another equation, x squared plus y squared plus 2hx plus 2ky plus c equals 0. Okay, if you divide by -2 for these two terms, you will get the center. And the radius equals the square root of these two, the coordinates of the center square minus c, which is this value. Okay, these are all the rules of the circle. Okay. Um, let's see some exercises. Here, find the measure of each central angle, each corresponding to the minor arc. Okay, this angle, its measure is 55, same like the opposite arc. Okay, and also this angle, its measure is 130. He needs the angle UTV. Okay, UTV is this angle. So, the measure of this angle, okay, can be found because all these angles, the accumulative angles, their sum equals 360. So if you make 360 minus the sum of all of them, 55 plus 95 plus 130 will get the result. Okay. And also the next one, find the length of each arc. Keep your answer in terms of pi. Okay. So I need the length of this arc. Okay. So to get the length of the arc, it's x degree over 360 equals the length of arc over 2 by r. The x degree is the measure of this angle. Okay. So 300 over 360 equal length of arc, which we are going to get, over 2 pi, and the radius is 11. Okay, and after that you will cross product to get the answer. Okay, the next one, the same. It's the same also. You will make 315 over 360 equal length of arc over 2 by 6, and then cross product. After that, here in this example, solve for x. Assume that the lines lines which appear to be diameters are actual diameters. Okay, so this is a diameter. If this is a diameter, so all this angle is 180 supplementary or straight angle. Yeah, I'm sorry, but for these two angles are supplementary. So if this angle 43, you will subtract 180 minus 43 to get the result. Okay, so it's 137. After that, so this angle will be equated to this measure. So x plus 139 equals 137, and then transfer this number to the other side with negative sign. So x equals -2. This is the measure of x. Okay. The next one, find the area of the shaded segment. Okay. Keep your answer in terms of pi. Okay, this one, I need to get the area. Okay, so x degree over 360. I will not speak about length of arc. I will get the area of sector. Okay, over by r square. So x degree, which is 300 over 360, equals the area of sector over pi r 14 square, and then cross multiply or shift to solve whatever. The next one is the same also. 60 over 360 equals the area of sector over pi r square. Okay. The next one, find the area of the shaded segment and round your answer to the nearest tenth. It's the same also example. This one, number 11. Number 11, find the angle measure indicated. Okay. So I need to get this angle. The tangents are tangents. Okay. So this is a tangent and this is a radius. So they are perpendicular, and the same here, perpendicular between the tangent and the radius. And this angle, okay, it's a 31. Since this is a radius and this is also a radius, so this triangle is isosceles. Okay, this triangle is isosceles. So base angles are equal. This angle equals this angle. So this is also 31. Okay, and regarding this angle, since it's 90, so 90 minus 31 will be 59, and this is also 59. Okay, and these two segments are equal, because it's a rule, because the two tangent segments are equal in measure if they are intersected outside the circle. So to get this angle, you will make in this triangle 180 minus both angles to get this measure. Okay, so it's 180 minus 59 plus 59. Okay, it will be 22. Okay, so this angle measure is 22. That's it. Okay. Another example. Okay. So here it's 62. I'm sorry. Okay. The next exercise. Because since this is 31 and this is 59, 59. So 59 plus 59 equals, this is the 118. So 180 minus 118 will get 62. Okay, so this angle is 62. That's it. The next one, find the perimeter of each polygon. Assume that the lines which appear to be tangents are tangents. Okay, so this equals this. So this is 10, and also here 14 and 14, and 18.6 minus 14 will get here 4.6, because 18.6 is all. Okay, so minus 14 will get a 4.6. And also 10.6 will be here 10.6. Okay, and also here 4.6. Okay, to get the perimeter by, you will add all these segments. Okay, and the next one, solve for x. Okay, this equals this because this is a tangent and this is a tangent, and the two tangent segments, if they are intersected outside the circle, so they are equal in limit. Okay, so this equals this. You will make 4x minus 4 equals 2x plus 16, and then I will solve the equation. Okay, you will transfer or make يعني combine the like terms. 2x will go to the other side with negative sign, 4x minus 2x, and here 16 plus 4, because negative 4 will be positive 4. This is will be 20, and this is will be 2x divided by 2, so x equals 10. Okay, in this example, radius and tangent are perpendicular, and this is 16 and this is 8 and 12, so this is all will be 20 to get the length of the radius. Okay, so radius equals square root, this is we are used theorem. It's 20 square minus 16 square. Okay, because we are going to get a leg, okay, not a hypotenuse. um that's it. Okay. هو in this example يعني it's not to get this length. He is saying determine if AB is a tangent. Okay, so if this radius and it's a 12, this is also will be 12. Okay, so what you are going to do is you will make the Pythagorean triple. Okay, and this is 12 square plus 16 square, and you will get the answer. Okay, separately, and then here it's a 20 square, and you will get the answer separately. If this equals this, so this is a Pythagorean triple, so this is the right angle, then AB is a tangent. If this is not equal, they are not equal, so AB is not a tangent. Okay. Um, that's it يعني. Okay. Thank you.